Just looking at these two problems, can you tell what kind of problems we are going to solve here? Rates of change, related rates, or exponential growth? Okay, so if you have guessed related rates, then you're right. Just reading the problems, suppose y is this function where x and y are functions of t. We have to solve number A. If dx change in x is 3, find change in y when x is equal to 4. The very first thing we are going to do, as we have done previously, this is a continuation of the first video before this about related rates. Okay, let's first rewrite this function in the simplest form, or however you prefer. This is much easier to see the power rule being applied here. Take the derivative, power in multiplication, and this is going to be power negative 1 or 2. Since this is a related rates problem, so don't forget you take the derivative of the inner function as well. And this is a constant multiply. So 2 is a constant times derivative of x is 1, but with respect to this function x, since x and y are functions of t, so dx over dt, and plus derivative of 1 is 0 since this is a constant. Okay, let's see. So what we have now, dy over dt, in we're gonna rewrite this back into its original format. So 1 over 2. So bring back to the bottom, so it becomes positive square root. So 2x plus 1 multiply by 2, right? So 2 times dx over dt. 2 cancels out. We have given that dx over dt is 3. And find dy over dt when x is equal to 4. And that is also given. So now we are going to plug in the values here. Simply 2 times 3. No, sorry. This is 4. X is 4. X is 4 here times dx of dt given 3. We have 3 over square root of 9, which is 3, right? 3 square. And the square cancels out with square root. So we are left with 3. 3 is the 1. So dy over dt is equal to 1 here. If dy over dt is equal to 5, find dx over dt when x is equal to 12. Okay, so we have this original equation here, right, that we can use for the part B. It was simply 1 over square root of 2x plus 1 times dx over dt. dy over dt is given 5 and x is equal to 12. We have to find dx over dt, change in x with respect to time. So what we have is 5 is equal to 1 over 12 times 2 is 24 plus 1. So this is 25, right? And square root of 25 is 5, right? 5 times 5 is 25. So this is like 5 square, cancels out. We are left with 5. Cross multiply this one over here. So this is 5 times 5 is 25 is equal to dx over dt. This is your answer for this one. Okay, moving on to number 6 now. If we have this equation given x squared plus y squared plus c squared is 9, and dx over dt is 5 and dy over dt is 4. Find dz over dt when this at these points x y z points are given, right? Okay, let's, since this is equation, so you know that implicit differentiation, which means you have to take a derivative on both sides of the equation. So you have to take the derivative. Okay, now derivative of each. Okay, so derivative of x squared is 2x with dx dt, right, with respect to x, plus, since this is, because this is different x y z, this is not a simple one. X y z are all functions of t. Same thing here, 2y dy over dt plus 2 times z dy over, sorry, dz with respect to z, and derivative of constant is 0. Okay, 2 is a common here. You can either take 2 and then divide by that, or let's see, since we have some values given, and you can divide by, take the 2 common here, plus z, right, so 2 we have here, so divide by 2 on both sides, so this is still 0, and this one is gone, so we have 0 here, and what we are left with is x dx over, and now we can just plug in the points and the values we have. So we have 2 x dx over dt is 5 plus y is, point y is 2 and dy over dt is 4 plus z is 1 and dz over dt we have to find. So 10 plus 8 plus dz over dt equal to 0, which implies we have dz over dt is equal to negative 18. Correct? It was positive on this side, so it goes to this side and it becomes negative. Okay, moving on to number 7 now. Two cars start moving from the same point. Okay, suppose both cars are here and start moving from the same point. One travels south. Okay, suppose and the other travels west. Okay, let x with a car that travels west at 25 miles per hour. That means we have given dx over dt is equal to 25 miles per hour, and let y be the car that travels south at at 60 miles per hour. So dy over dt 60 miles per hour. And at what rate is the distance between the cars increasing 2 hours later? and this is what we are trying to find here. Let z be the distance between the two cars, and the relation between these three can be Pythagoras theorem, right? So a square plus b square is equal to c square, right? And in the given situation, hypotenuse is z here. Okay, and let's, since this is equation implicit differentiation, so take the derivative on both sides of the equation. Okay, let me write this nicely. Let's check the derivative. Derivative of x square is 2x, and with respect to x is dx over dt plus 2y dy over dt equal to 2 times z and dz over dt. Cars increasing 2 hours later. So we are trying to find the distance between the cars, the rate of change after 2 hours, right? So that means we have to multiply this x multiply by 2. So after 2 hours, where how far these cars would have been already. So x is going to be 25 multiplied by 2, 50 miles per hour, and y is going to be 60 times 2, 120. Okay, so 2 times 50 times dx over dt is 25 plus 2 times y is 120 and dx dy over dt is 60. 2 times, since this is a Pythagoras theorem, right? So we can find the z here if we don't know the rate, at what rate it's changing. So a square plus b square is equal to z square, right? So we have 25 times 25, 625 plus 3600 square root is equal to z. So z is equal to 65, and 65 times by 2. So we have figured out that z is equal to 65. And so since we are calculating after 2 hours, right? So you have to apply as we have done here after 2 hours. And here z is also going to be 65 times 2, which is equal to 130 miles per hour. So we have z 130, and we just have to find out what rate it's. Okay, let's see what we get here. Take your calculators. We have 50 times 2, 100 times 25, 2500 plus 120 times 2, which is 240, times 60, which is 14,400, divided by 2 times 130. So 260. So this is simply going to be 2500 plus 14,400, which is 16,900, divided by 260, 65. 65 miles per hour. dz over dt is equal to. So at 65 miles per hour rate, the distance between the cars is increasing 2 hours later. I really hope this makes sense. Okay, let's look at the very last problem from this topic, related rates. The altitude of a triangle is increasing at a rate of 1 centimeter per minute. Centimeter per minute. Okay, let's draw a triangle here. Suppose we have this triangle. While the area of the triangle is increasing, at what rate is the base of the triangle? Okay, this is the base. Suppose B is the base of the triangle. Altitude increases, that means height, right? This H. And first of all, what is the area of the triangle? Half times base time height, right? And the altitude of the triangle is increasing at a rate of this. So we have dh over dt given 1 centimeter per minute. And area of the triangle is increasing. Okay, area rate of is 2 centimeter square per minute. At what rate is the base of the triangle changing? We have to find dv over dt. When the altitude is 10 centimeter, and we have given that h is equal to 10 centimeter. This is 10 height, and the area given is also 100 centimeter Now this is easy to solve, right? And first of all, let's take the derivative on both sides of the equation. So we have dA over dt is equal to, bring the constant out, constant multiply rule here, so product rule here, a times derivative of b, which is derivative of h is 1, and dh over dt, plus a times derivative of b plus b, which is h, times derivative of a is b derivative of b is 1, and the rate of with respect to time is dv over dt. Okay, we have given dA over dt is 2, say 2 half, we have b is base. If we already have height, we can, and area, we can calculate the base as well, right, as we have done previously. So area is half times base times h. Area is 100, half times base times height is 10. 2 5 so 10, divide by 5, so it's going to be 20 centimeter. B is equal to, we have just calculated that B is equal to 20 centimeter. So 20 multiply dh over dt, which is 1, plus h height is 10, and dv over dt is unknown. Okay, cross multiply this one here. 2 times 2 is 4 is equal to 20 plus 10 dv over dt, and we are solving for the rate of change for the base. So we have 4 minus 20 divided by 10 is equal to dv over dt, and this is going to be negative 16 over 10, right? So which is simply dv over dt. At what rate is the base of the triangle changing when the altitude is 10 centimeter and the area is 100 centimeter square? At negative 1.6 centimeter per minute. So at this rate, the base of the triangle changing when the altitude is 10 centimeter and the area is 100 centimeter square. So I hope this all makes sense. Thank you so much for watching.